Okay, we're moving on to Unit 1.6 in math, which is exploring the Pythagorean Theorem. And so far we've been looking at right triangles, right here. Right, we have a right triangle there. And we know that the Pythagorean Theorem works with right triangles. But there are two other types of triangles that we want to see. Well, does it work with them? So we have obtuse triangles, and we have acute triangles. An obtuse triangle is when you have an angle here that is greater than 90 degrees, and acute triangle is a triangle where you have an angle that is less than 90 degrees. All right, so when we take a look and we apply the Pythagorean theorem to the right triangle, we know that a squared plus b squared equals c squared. So if we take a look at this, we have 6 squared, I don't know where that line came from. Try this again. 6 squared plus 8 squared should equal c squared. So we have 36 plus 64 equals, in this case, it's 10 squared, which is 100 equals 100. So yes, there's the Pythagorean theorem in action. A squared plus b squared does equal c squared. But if we have an obtuse triangle, we go a squared plus b squared equals c squared. Does it work? We have 6 squared plus 8 squared equals 12 squared. And so we have 36 plus 64 equals 144. And we say 100 equals 144. We look at this and we say, no, it does not equal. So we draw a line through here and we say 100 does not equal 144. So the Pythagorean theorem doesn't work for obtuse triangles. And what you notice here, you notice that the area of side C is larger than the area of A and B combined. So we know it's an obtuse triangle when the area of the longest side is larger than the areas of the squares of the two shorter sides. Well, let's take a look at an acute. A squared plus b squared equals c squared. That's our Pythagorean theorem. So we go, again, 6 squared plus 8 squared should equal 9 squared. We go 36 plus 64 equals 81. We have 100 equals 81, and we say, no, it doesn't equal 81. Therefore, the Pythagorean theorem doesn't work. And if we notice, 81, the square of the longest side is less than the combined squares of the two shorter sides. So we have 181, so we know if it's less, it's an acute triangle. All right? Now, another term that we're going to learn here is if we take a look at this, these numbers, 6, 8, and 10. We notice, okay, those are the dimensions of this right triangle, 6, 8, and 10. These three numbers, because they, when you apply the Pythagorean theorem to them, the two shorter sides, you square them, all right, and add them together equals the sum, the square of the longer side. These three numbers make up what's known as a Pythagorean triple. And basically what that says is those three numbers, when you apply the Pythagorean theorem to them, the two smaller numbers, square them and add those together equals the square of the larger number. Well, let's apply it to three other numbers. Let's go, let's try applying and seeing if the Pythagorean triple works for 3, 4, and 5. So to test this out, we simply go 3 squared plus 4 squared should equal 5 squared. And so we go 9 plus 16 equals 25. 25 equals 25. So we know, yeah, this works. These three numbers equal a Pythagorean triple. All right, well, let's choose 3 more numbers and see if this works. How about 7, 12, and 18. So we take a look here. We go, okay, well, let's go 7 squared plus 12 squared equals 18 squared. And we check that out on our calculator. We know 49 plus 144 is 12 squared. And 18 squared is, double check this here, is 324. So if we add these together, we have 144 plus 49 equals 193, right? Which equals 324. And we say, no, 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 no. 7, 12, and 8 is not a Pythagorean triple. And basically, Unit 1.6 is all about testing to see whether a set of 3 numbers is a Pythagorean triple. All right?